I'm Dr. Mackenzie. I'm a professor of neuropathology at the University of British Columbia in Vancouver. Identifying causal genes in disease in general is important because it tells us something about the underlying pathways that cause the disease, which in turn give us some ideas about how we might be able to treat it. So obviously identifying genes is particularly helpful to families who have those certain mutations. You can provide genetic counseling, you can identify patients at risk, but I think in the larger scale, really what that information provides is it tells us what biological processes are going wrong in the disease, and in turn that gives us some ideas about how we might be able to treat it, fix it, approach it, at least in a more rational fashion. Where we are at the moment in ALS, I think the last decade has seen an enormous number of new gene discoveries, which has been very encouraging. Most of them are genes that cause that small proportion of the disease which is inherited in an autosomal dominant fashion, which only represents about 10% of ALS. What we still don't know very much about, though, are the genetic factors that increase risk or that may have a more sort of subtle effect, which is still of biologic importance. And so there's still a lot of work that needs to be done, and a lot of that actually can't be done with just small collections of patients. You really need enormous collections of multiple samples in order to do that kind of analysis. Project MinE is a good example. It's a collaborative project that's bringing together samples from different areas of the world, different labs, different researchers, with an accumulation of genetic material that no single lab or even any single country would be able to accumulate on their own. So it's got the advantage of some degree of ethnic diversity, but even equally important, it's just got an advantage in numbers. It's got large numbers of cases that then allow you to identify factors that have a more subtle effect through these sorts of association analyses that we can do with not just the large number of ALS samples, but also the large number of control samples that are nicely matched with the patient samples. We're actually using samples that we've already got available. So most of these are samples we've collected over the last several years that we have existing in our biobank, so they're basically ready to go. The samples are there, the DNA has been purified, and it's available for genetic sequencing. We're just waiting for the green light to go ahead and get that done, which of course requires funding. So it's really just waiting to be told that the funds are available to do that whole genome sequencing. Donor dollars would be extremely helpful. Government dollars would be very helpful. Any dollars that would support this project, I think, would be helpful and move it forward tremendously.